All right, so back in the middle of this synthetic division, we're in problem number 5, and if you'll look at this, there's no work to be done. And I want to show you why this is not going to work out. When you're looking at this problem, synthetic division would not work on this problem because what you're dividing by has an exponent bigger than 1. Synthetic division is the shortcut, but it's only used for polynomials that you're dividing by, whether it's x plus a number or x minus a number. It could have 2x plus 5 or 3x minus 4. It can have a number in front of the x, but it just can't have an exponent 2 or bigger. Now, with that being said, you can divide this, but you'd have to do long division where you say x squared plus 0x minus 3 in front of all of that stuff there and just do the same thing we did on the last lesson. It's not that you can't divide, it's just that synthetic division won't work on that problem. So if they ask you to do synthetic division, which I doubt they will on a problem like this, but one thing they might ask you to do is to do divide these polynomials and choose your method. Well, there's really no choice. You can't choose to do synthetic division. You'd have to do long division on that. Okay? All right, so here's problem number 6. Problem number 6 is synthetic division. It's the first time we see a number in front of the x. That actually changes synthetic division 2 different ways. All right? The first thing we got to do is find the root of that. If you have to, you can set it equal to 0 and solve, but the shortcut is just change the sign of the back number and divide by the front number. The root is 3 over 2. I didn't write that right. 3 over 2. Okay? So that's the root. Then set this up the same way where you say 2, 5, negative 22, and 15. Skip a line, draw a line. Synthetic division starts by dropping the front number and then multiply this times the box. Keep in mind, when I'm multiplying 2 times 3 halves, do the division first. This is a bottom number divided into the whole number. 2 goes into 2 one time. 1 times 3 is 3 for the next column, and add. Then do it again. 2 goes into 8 4 times. 4 times 3 is 12. Add, it's negative 10. 2 goes into negative 10. Negative 5 times. Negative 5 times 3 is a negative 15. And add. This tells me my remainder is 0, so I don't have to write anything with the remainder, but here's the deal. I'm not done yet. There are 2 things that are going to change on these problems if there's a number in front of the x. The first thing is that your root's going to have a fraction in it. That's easy to take care of, but the second thing is, and you have to remember this is the most missed type of problem on synthetic division. If there's a number in front of the x, you must divide this row of numbers by 2, by that number in front of the x, before you write your answer. So you'll divide 2 into each one of those. 2 goes into 2 one time, 2 goes into 8 4 times, and 2 goes into negative 10, negative 5. These are the numbers you're going to use to write your answer. Since that started off as x to the third, 1 goes in front of x squared plus 4x minus 5, and there's your answer. So don't forget, if there's a number in front of the x, 2 things change. There's going to be a fraction in the box, and you must divide your final answer. You don't divide the remainder because you're putting the remainder over the 2x minus 3 that's still there. So you don't divide the remainder by that. You just divide the numbers that are in the polynomial, the coefficients, if you would. So on this problem, again, if you want to take a shot at this before, just press pause right now. But I'll go ahead and do it now. Your 0 is negative 1/3. The numbers in order, don't forget you're looking for zeros. If anything gets skipped, which in this problem nothing did, it went 4, 3, 2, 1, and 0 with the exponents. Skip a line and draw a line. Drop the front number, it's a 6. And you multiply 6 times a negative 1/3. 3 goes into 6 2 times. 2 times a negative 1 is a negative 2, and add. 3 goes into 3 one time. 1 times a negative 1, and add. 0 times anything is 0, and then bring down that negative 3. 3 goes into negative 3, negative 1. Negative 1 times negative 1 is a positive 1, and that gives you a positive 2 as a remainder. So the 2 things that are changing, number 1, you have a fraction in for the root. The second thing is, don't forget you go and divide all of these by that 3. 6 divided by 3 is 2. 1, 0, -1. You do not divide the remainder. So now write your answer. Since that was x to the 4th, that goes in front of x to the 3rd. That goes in front of x squared. You can write the 0x, but you don't have to. And then -1, and the 2 goes over what you're dividing by. So the answer you would actually see in the back of the book is going to be 2x cubed plus x squared minus 1 plus 2 over 3x plus 1. Got it? All right. So doing good so far. Got one more type of problem from the synthetic division thing, and this one's where it gets a little ugly because it deals with imaginary numbers. All right. Imaginary numbers, though, don't change much of anything. First of all, we need the root of the thing you're dividing by. We said if you can't just look at it and see it, set it equal to 0. I'll do it right down here. X minus 1 plus I. Set it equal to 0 and solve. Subtract the I and add the 1 over. It becomes a positive 1 and a negative I. There's the root right there. I got x by itself. So the number that goes in the box is 1 minus I. Then write down the numbers in front of each of the x's in order. There's x to the 3rd, x squared, x, and nothing. So nothing's got skipped. So it's going to be -3, 5 minus 2i, -4 plus I, and then 1 minus I. Those are my 4 terms. Skip a line, draw a line. Drop the first number and start there. Multiply that times the box. You're going to have to distribute this. You got to say -3 times 1 and -3 times a negative I, which is a positive 3i. Now add. It's going to give you 2 plus I. Now you got to say 1 minus I times 2 plus I. And keep in mind, if you're going to multiply these, 1 minus I times 2 plus I, you got to full it out. You got to say 1 times 2, 1 times I, negative I times 2, that's negative, sorry, oops, negative 2I, and negative I times I is a negative I squared. When you add like terms, that gives you a negative I in the middle. Don't forget that's a -1, so it's 2 minus a -1. So 2 plus 1 is 3. So that's going to be 3 minus I right there. Add like terms, that gives you a -1. Those cancel out, it's just -1. Now multiply -1 times both those. It gives you a -1 and a positive I, and when you add those together, it gives you 0 as a remainder. It's kind of ugly, but it's very doable. Don't forget to go back and write your answers. Since that was x to the 3rd, that goes in front of x squared. It'd be -3x squared plus 2 plus I x minus 1 and no remainder. That's your answer. That was fun. Now, there's one other type of problem they're going to ask you to do on this section. And the directions will say construct a polynomial. And they'll give you some details that they want you to take care of inside of this. Here's the 2 examples they're using. The first one is it's a 3rd degree, meaning it's going to have an x to the 3rd power as the highest thing. If there's more than that, it'd be a 4th degree or 5th degree or whatever else. So this is a cubic. It's going to be an x to the 3rd as the highest thing. They tell you your zeros are -3, 2, and 5, and it goes to negative infinity as x goes to positive infinity. We're going to knock that out last. Let's take care of our zeros because that's easy. First, let's name our polynomial. I'll call it f of x. I know that there is 3 roots because they gave them to me. They are x plus 3 because that's what -3 is the root of. That's going to be x minus 2 because if I plug in 2 there, that's a 0. And then the last one's going to be x minus 5. So there's my 3 roots. I've taken care of this part of it. The next thing is look to see if it's a third degree. Notice if I multiply these out, I would have x times x times x. That's x to the third. This by itself is already a third degree. I've taken care of that part of it. The only other thing to take care of is as that the function goes to negative infinity as x goes to infinity. Now think about it. Remember from last lesson, from this last week, it's saying as x gets really big, that's going out here to the right, they want the function to be going down. To do n behaviors, to get the right side to go down, to get the right side of the polynomial to go down, I need the leading coefficient to be a negative. Which means if I just put a negative number, -2, -4, doesn't matter, -1, I can just put a negative there. That puts a negative in front of this thing, then that is a third degree polynomial with those zeros that goes downhill as x goes big. This is not a root because it doesn't have anything to do with an x. Do you see that? The number sitting out here, if it doesn't have an x, it has nothing to do with another 0 or anything like that. So you can put any negative number you want to right there and it answers this question. But your 3 roots are -3, 2, and 5. That's why you have to have those 3. Now let me just say this. If they ask for a 4th degree polynomial, but they only give you 3 zeros, then you need to square one of these parentheses by putting a 2 outside the parentheses there, because that'll make one of them x squared with an x and x. That'd be 2, 3, and 4. Does that make sense? If they ask for a 4th degree, but they only gave you 3 zeros, that's one of the things in the homework that I don't have an example for. You'll be watching for that. So for this one, 4th degree polynomial, so it's got to have an x to the 4th. They gave me 4 zeros, which is going to help with the whole 4th degree part of this. And then they also tell you the y-intercept is 0, 15. All right? So let's go ahead and name our function. I'll call this one g of x. Let's take care of the zeros first because those are always the easiest thing to take care of. My zeros are going to be x plus 5, x plus 2, x minus 1, and x minus 3. Because remember, when you're actually solving these, you change the signs. So to go backwards, you're going to change the signs again. All right? So the next thing you're going to do is make sure it's a 4th degree. Well, you got 1, 2, 3, 4 x's being multiplied together. That's a 4th degree already. That's already taken care of. Again, if they said 4th degree and they only gave you 3 zeros, you would have to go back and change an exponent somewhere along the way to make it a 4th degree. But this one works out nice and easily. The last thing it says is that they want the y-intercept at 0, 15. Now don't forget, there can be a number and will be a number sitting right there. I'll call it A, okay? I need to figure out what number needs to go there to make all of this fit that thing right there. Now, what do you know about y-intercepts? Y-intercepts is always where the x is 0. So to find out what A is, I'm going to plug in 0 and 15 for the x's and the y and see what A is. Put 15 in for the y, and everywhere I see an x, put a 0. And let's clean that up. And let's see if we can figure out what A, the number in front of this thing, has to be. 0 plus 5 is 5. 0 plus 2 is 2. 0 minus 1 is a -1. And 0 minus 3 is a -3. That'd be 15 is equal to, it's 5 times 2 times -1 times -3. That's a positive 30. So to solve this equation, it's just A times 30. Just divide both sides by 30. And what does 15 over 30 turn out to be? It's 1/2. So my function, g of x, simply needs the number 1/2 in front of x plus 5, x plus 2, x minus 1, and x minus 3. This is my polynomial they were dealing with. Okay? So just making sure you understand how to do that. The way that you're going to go through this, whenever you're constructing a polynomial, write down your zeros first. Make sure it fits the right degree. If not, change one of the exponents. And then whatever the final characteristic is, do what it says. The last one just talked about the end behaviors. This one talked about y-intercepts, both of which we should be getting pretty good at by now. All right? All right. So just letting you know, your assignment, which is going to be emailed to me, is going to be page 386. You got 1 through 33, that's the long division and synthetic division, and then 41 through 59, that's going to be the constructing the polynomials, and that's odds on both sections, odds all the way through. I'll try to remember to post the answers for the odds with the problems as well, okay? Don't wait till the last minute, people. Good luck.